Welcome back, everyone. This is the last in a series of problem sets for Chemistry 1220 Midterm 2 review. So dealing with Chapter 17, additional aspects of aqueous equilibria. So the problem reads, a 20.00 milliliter sample of 0.2 molar HBr solution is titrated with 0.2 molar NaOH solution. Calculate the pH of the resulting solution after the following volumes of base have been added. So remember, as soon as we titrate, we need to keep in mind that we are neutralizing acid with base. Thus, the first ice table that we need will be a mole. It will be measured in moles. So we write the equation, HBr plus NaOH gives us NaBr, a salt and water, right? So this is a mole table. So we have 0.2 molar. So we need to figure out moles, right? So remember how I said earlier that when we have a molarity and we have a volume, I like to multiply them to get moles. So 0.2 moles per liter times 0.02 liters. Okay, liters will cancel, and we will get 0.004 moles of HBr. Okay, make that a little neater. Okay. And now we are going to add 15.0 mils of NaOH. So again, 0.2 molar is 1 mole per liter times 0.015 liters. Oops, that came out wrong. Okay, and so we will have 0.003 moles. So maybe for some of you this brings back the memories, maybe for some others the nightmares, of stoichiometry. So we need to figure out what is the hydrogen concentration remaining in solution after we've added the base. So we need to figure out the limiting reactant, and the limiting reactant will be the base. So we will have some H plus left in solution. So we're going to run this to completion, so we need to subtract all the moles that we added to the base. This is like our change. Okay. So we'll get 0 moles remaining of NaOH, but 0.001 moles of H+. So remember, HBr is a strong acid, thus the pH will be the negative log of the concentration. So what's the concentration of H+? Well, we have the moles. Remember that molarity equals moles of solute per liter of solution. So our moles is 0.001 divided by liters of solution. So remember, it's the 15 mils plus the 20 mils. Whoops. So total we have 35 milliliters, or 0.035 liters. So we divide, and we will have 0.029. So again, take the negative log of that, and we get 1.5. That would be the pH of the solution. Okay. Okay. Moving on. 19.9 mils. So again, it's the same setup. So we're again going to start out with our 0.004 moles of HBr. But now we have 19.9 mils. So now we take our 0.2 molar of NaOH times, so 19.9 is equal to 0.0199 liters times our 0.2 molar. So we're actually going to have 0.00398 moles. So now our limiting reactant is, again, the NaOH. So we use all of it up. So 0.004 minus 0.00398 is 2 times 10 to the negative fifth moles. Okay, so again, we need to do moles per liter, so 2 times 10 to the negative fifth moles of that H plus divided by total liters. So again, we had a 20 mil sample plus 19.9 divided by 1,000, so we're going to get 0.0399 liters. And we take the negative log of that result, which will be 5.01 times 10 to the negative fourth. And our answer is 3.29. Okay, so as you can see, we have 1.5. We add a little bit more base here, right? So our pH is slowly increasing. Okay, slowly increasing. So what do you think will happen with 20 mils? Okay, obviously we're adding more base, therefore the pH will continue to rise. Notice that in part C, we go from 19.9 milliliters to 20. So we're only adding 1/10 of a milliliter. Okay. So let's go ahead and set the problem up just like we've been doing. So again, we'll have our HBr plus NaOH. We'll write that a little bit. Gives us NaBr, water. Again, we start with our 0.004. Now we do our, we're also going to have 0.004 moles of each. So again, we use all of it up. And you notice that we have no H plus, no OH minus, extra. Thus, our pH equals 7. Neutral. So that's how you do these types of problems. When you neutralize, aka titrate, you need to take into account that you actually need to do a mole ice table first. And if the acid is a strong acid, you can just take the negative log of the H plus concentration to find the pH. If the acid is a weak acid, then you need to do an ice table and you need the Ka of that weak acid to further solve for the pH. So thanks for watching. Good luck on your exam.